Morning.
How was your long weekend?
It's alright.
Yeah.
I didn't get as much done as I wanted, but how was yours?
It's pretty good.
Yeah.
I got the exact amount of work that I needed to get done, which was 0.
Thank you.
Here, you need to fill out the top part,
I'm sorry.
because I can't do it right now, and I'm going to forget who gave it to me.
Thank you.
I'll get it to you. Well, just enjoy it while you can, because the older you get, the more your to-do list moves. Yeah.
Should I staple the pages of it?
Get as much as I had like older like 6 answers, but I learned in my last
Yeah.
so
I really mind like sharing.
yeah.
I've definitely asked for my share. Anytime. I thought that things today was 6:30 because it was like less than a minute about
I think it's just 8.
Yeah. I hope so.
Better not. Yeah, you do. Just questions. I really not about this.
Yeah, it's pretty 8 and 9.
I was saying I was good.
Oh my god, you think this one?
Yes.
I
So
that's pretty good.
I never thought.
Is it like a brand new?
It's the 15 It's so nice. I'm watching movies on it.
Really? I think when I get a new one for college, like if mine is running, like every one computer I have to it really is.
Didn't you cry like every key on it?
Yes, literally, like it just needs to be put down.
For real, yeah.
So first, hey, why Stuart Queen. Are y'all pulling it? I'm so excited. Did you join the Revine?
No.
I will. There's like a ton of my band-aid. There's like a ton of I can also do
Wait, I want to use this in mine.
You are?
I was in last year.
So we made a new one. I
Take that off.
8 and 9, but he doesn't have the
I'm so glad I'm not taking Spanish.
played football during COVID today, so I had to Did you do that thing work?
Where?
Right, I think that'll work.
Oh, sorry. While everybody was over
I
there.
got both of them. Oh, really? I need to
Okay, I'm asking for 2 assignments this morning, number 8 and number 9. If you did not put those in Google Classroom, make sure your name's on both and come put it in the basket up here.
And it is so good.
No, I didn't forget.
I have to air it out. Like what?
This was like
Yeah.
I can.
Like that?
Yes.
I'm literally going.
Do you want the grade for thing right now or later?
I need to
Yep.
Thank you.
Okay, I also need you to find assignment 10 and 11 in your binder. 8 and 9 need to be turned in. 10 and 11 get out.
I remember I like recently like practicing my screen started to the back of my phone track. I like YouTube in the shower. And I always end up, as soon as I'm in the room, I always end up jumping in the shower. Wait, like, I'm huge shower. Well, because like, in my shower, there's like 2 plugs that go into the wall. So I like just like set it up in there. I leave my I don't get it.
I better grab my phone.
Okay, let's get started, please.
I just put it in plastic bag because it would pop open.
All right, as always, if you forgot to do that, remember you can still get half credit as long as I get them before our quiz/test. Okay, another assignment that we did last class was assignment 10, and I did not ask you to turn assignment 10 in because most of you were working on that when you left last time. So there's a good chance you have a couple questions you want to ask from that. So, is there any question that once you check your answers and you were outside of class that you realized you needed help with on assignment 10? I don't mind, but you guys need to be finding that real fast if you have something. Yeah.
Could you do 12?
Question 12. Okay, this 12? Okay, so what comes up in my head when I read this question 12 is it wants to know the limit as x approaches 3. So whether you're talking about a graph, a table, a piecewise function, whatever, for this limit to exist, because there's a chance it doesn't exist, we need to think about what's the limit as it comes from the left and what is the limit as it comes from the right. Okay, so from the left is x value smaller than 3, so that would get plugged in here when x is less than 3, and you'd get the natural log of 3 times 3. You okay with where that's coming from? Yeah? Okay. And then for the right side, as x approaches 3 from the right, that's going to be slightly bigger than 3, so that would get plugged in here where it says x is bigger than 3. Bless you. So if I plug a 3 into that, I get 3 natural log of 3. So the limit from the left is natural log of 9. The limit from the right is 3 natural log of 3. Are these the same? What's another way we could make this look, just in case?
Natural log of 3 to
Okay, very good. We could bring this 3 up, and we could write it as this. But if the limit from the left does not equal the limit from the right, then that limit doesn't exist. So you should get does not exist for 12. Looks like 13 is very similar too. Is that okay? Okay. All right, others from assignment 10? Okay, then let's kind of want to go out of order just a little bit of what the agenda says, but let's jump to today's handout, assignment 12. All right, so last time, in about 30 seconds, I talked about types of discontinuity. And there was the jump, the infinite, and the removable. And I barely even mentioned those to you, but all of those do show up on the AP exam, which means they are likely to show up for our first assessment, which means we need to practice them a little bit more than what I did last time. So just very briefly, the idea of being continuous is you've got a nice smooth graph. If you know a point on that graph, then you know there's going to be a point right before it and a point right after it. Whereas to be not continuous or discontinuous, there's some sort of break in the graph, whether that's a hole or a vertical asymptote or the graph jumps. There's some sort of break in the graph. So if you have the graph, you can generally eyeball it and quickly say yes, it's continuous, or no, it's not continuous. But sometimes we don't know what the graph looks like, and we need to be able to say in words what type of discontinuity it is and why is it continuous. So this is actually a repeat of what we talked about last class, but I want your notes to be a little bit better here. Let's come back to number 1, because that's the one I worry about. So number 2, if your graph goes to infinity and to negative infinity, aka you've got a vertical asymptote, this is what we call an infinite limit. Or I'm sorry, infinite discontinuity. Infinite discontinuity. That one students generally remember because it's going to infinity, it's going to negative infinity, it's called infinite discontinuity. In question 3, it looks like it was here and then it jumps up to here. So this is an example of what's called jump discontinuity. And then the one that I'm concerned about, because its name is not intuitive, is when you have a hole, the first one. Whether it's a hole and the point doesn't exist, or if it's a hole and the point exists somewhere else. Either way, does anyone remember what we call that type of discontinuity?
Removable.
Very good. Removable. Can't call it hole discontinuity. Even though I know what you mean, that's not a real word. Now, you should also add this to your notes here. This comes up occasionally. Holes are the only removable, so these other types are sometimes referred to as non-removable. So you may want to jot that down. Holes are the only removable type. The other two are sometimes referred to as non-removable. So a lot of what we're going to be doing on this worksheet is trying to find where are their holes, and we'll call them removable discontinuity. Where are their vertical asymptotes, we'll call it infinite discontinuity. And when is the graph jumping, we'll call it jump discontinuity. So we need to review the difference between a hole and a vertical asymptote. So I know this was the very last topic we did together in pre-calculus. But just as a quick reminder, if you get an x value that gives you 0 on top and 0 on bottom, that's how your function has a hole in it. If you have some number other than 0 divided by 0, that's how you get vertical asymptotes. And the one you don't really have to remember for this lesson, but I think they fit. If you have a big fraction and the numerator goes to 0, that means the whole fraction goes to 0, which means y goes to 0, and when y is 0, it's an x-intercept. But I really need to focus on these two. So to do this, I need to figure out what numbers make the numerator 0 and what numbers make the denominator 0. So that is often going to require some factoring. Once you factor it, you should be able to see pretty quickly what numbers make the denominator and numerator 0. Now again, when you did this in Algebra 2 / pre-calculus, this type of rational function, you answered everything about it. Vertical asymptotes, holes, horizontal asymptotes, slant asymptotes, x-intercepts, y-intercepts, put it all together on a graph. For our use in calculus, I just need to see that 2 makes the numerator and denominator 0, which is how you get a hole. So at x equals 2, I have removable discontinuity. And if there's any numbers that make only the denominator 0, that's going to create a vertical asymptote. But a vertical asymptote is known as infinite discontinuity. So those are the two places it is discontinuous and the two types that it would be. Now, for those of you trying to raise your ACT score, this idea of holes versus vertical asymptotes does show up on the ACT a lot. So you really need to know it for this class anyway, but there's a little more incentive if you're trying to raise your ACT score. Okay, I'm going to say the exact same thing on question 2. It's just that the numbers are going to probably be different, but I really need to know what numbers make the numerator 0, what numbers make the denominator 0. There's probably some factoring involved. Difference of two squares and then another difference of two squares. And then, because -1 makes the numerator and denominator 0, that creates a hole, but a hole we call removable discontinuity. And any number that makes just a denominator 0, like 1, is going to create a vertical asymptote, which we call infinite discontinuity. So, like a million calculus things, if you really remember how to find a vertical asymptote and how to find holes, then really the only other piece to this is knowing that holes are called infinite and vertical asymptotes, holes are called removable and vertical asymptotes are called infinite. That's really the only calculus part to that, is knowing the names at the end. Okay, everybody okay with that one too? Okay, let's skip 3. 3 is a tougher one, especially if you didn't do pre-calculus last year, but even if you did pre-cal, it'll be a tougher one. Okay, this one is not a big fraction, but of course you can make anything a fraction by putting 1 over it. So, what numbers make my numerator 0? Just my numerator. Okay. What numbers make my denominator 0? Nothing. 1 is never equal to 0. So, is there any numbers that make the numerator and denominator 0? That would be holes, removable discontinuity. Is there any numbers that make just the denominator 0? No. That would be vertical asymptotes, which we call infinite discontinuity. So this one is just always continuous. In fact, that one should make sense to you. Don't you know what this graph looks like? We all know what x squared looks like, and then the -1 just shifts it down 1. There's no breaks in that graph. The only time discontinuities are going to occur is if your graph's jumping from one value to the next, or if you're trying to divide by 0. Okay, then the tough one is the trig question. So first off, the first two, and kind of this one, I talked about numbers that made the numerator and the denominator 0. Well, this isn't a fraction, but we can change it to a fraction. Tangent is the same thing as sine divided by cosine. Now, there's lots of little things like this that show up in pre-cal that can be used in calculus, but as far as the trig identities go, they don't put you on the hook for too many of those. Knowing tangent is sine over cosine is certainly one of those. So, if you did pre-cal last year, there's no way you forgot that because you did it 10,000 times. But if you didn't do that, if you didn't take pre-cal last year, you need to learn that as soon as possible. Okay, so if I've got to figure out when does the numerator equal 0, between 0 and 2 pi, this is the problem. Solving this type of equation just isn't something we get to do on a regular basis. So, how I tell my pre-calculus students is pretend like this is an x. I'm going to highlight the 2x so I don't forget about it like I did second period today. And then I'm going to go around the unit circle once and label everywhere where sign is 0. It would be at 0, add pi, add pi. So the first one's at 0, and the others are integer multiples of pi away. Okay, so the first answer is at 0 radians, add pi to get to the next one, add pi to get to the next one. So this was like a formula that will give you all the solutions to this. But you need to be careful and realize you didn't really solve for x, you solved for 2x. I just replaced it with x to make it something I could do in my head. To go from 2x equals to 1x equals, I want to divide this by 2, so I'm going to divide this by 2 and divide this by 2. So this formula tells me the numbers that make sine of 2x equal to 0 are integer multiples of pi over 2. So when n is 0, when n is 1, when n is 2, when n is 3, when n is 4. And this is very unusual. In fact, this is probably a typo, but you don't normally include 0 and 2 pi. Notice how they have the equal to sign on both. Usually it's one or the other. Okay, I basically have to do the same thing for the denominator. So if I want to know when is cosine of 2x equals 0, I'm going to ask myself, when does cosine of x equal 0? Because I can just use my unit circle knowledge. Cosine of x is 0 when x is here at pi over 2. Plus you could add pi to get to the next answer, plus add pi to get to the next answer, add pi to get to the next answer. So plus integer multiples of pi. But once again, be careful. I don't really know what x is. I know what 2x is. Divide everything by 2, and now you have a formula that will give you all the solutions of cosine of 2x. So if n is 0, we get pi over 4. If n is 1, we would get pi over 4 plus pi over 2, which is 3 pi over 4. Add it again, we get 5 pi over 4. Add it again, we get 7 pi over 4. Add it again, we get, I don't know, 9 pi over 4, but that's bigger than 2 pi. Now again, that's a lot of information, but it should be familiar to you for those of you that did pre-cal. So at the end, the important piece here, notice there's no numbers that make the numerator and denominator 0. So this would have no holes in the graph. But there are numbers that make just the denominator 0. So when x equals pi over 4, or 3 pi over 4, or 5 pi over 4, or 7 pi over 4, we've got division by 0, which is what type of discontinuity? One more time? Infinite. Okay. So, we can learn from my mistakes here, but today in second period, I forgot to change this x equals to 2x equals, and so my answers were a little bit off here, and I only had 2 answers instead of 4 answers. But I was able to catch my mistake very quickly because I wanted to show them what we were doing. So notice, okay, that's the wrong graph. Is it tangent 2x? So notice between 0 and 2 pi, which is how I have the graph set up, there is 1, 2, 3, 4 times it's discontinuous. And that work we just did was to figure out where. This should be pi over 4, trace pi over 4 enter. When x is this, y doesn't exist, which matches up with this. And then 3 pi over 4 also is an asymptote. At 5 pi over 4, there's a third discontinuity. And at 7 pi over 4, there's another infinite discontinuity. So, of course, you don't always have a graph, but that's basically what we're doing here. We're doing the algebra to figure out where those are dividing by 0. Okay, so on this worksheet, I want you to come back to this one second, but basically do the same things. Think about where the numerator is 0 and denominator is 0 so that you can answer those. But before you go and do that, I would like you to work on assignment 11, please. So assignment 11 was where we took notes on continuity last time. So I'm going to give you the 30-second review of that. Although you should maybe spend a couple minutes scanning these before you go back and do these questions. But when you're asked, is it continuous at a point or prove it's continuous at a point, you should not be trying to rationalize that in your head and try to make sense of it in your head. You should be using the definition. We said to be continuous, there better be a point there. The graph better not be jumping around, meaning the limit has to exist, and the point's got to be where the limit is. All three parts of these. So, to figure out if it is continuous at a point, if it was continuous, we needed to state the point exists, the limit exists, and the point is equal to the limit. You have to say all three things if it was continuous. If it was not continuous, we just need to state one thing that was messed up. So, when x was -1, this value was something, this value was something else, so the graph is jumping. Okay, we talked about types of discontinuity, but we just talked about that on the other page, and then we get to this. So let's do this question 1. We'll do both parts of question 1, just kind of as a friendly refresh, and then I will ask you to focus on this assignment first, and I'll tell you where you need to, what you need to work on this class period. Okay, so again, this one has two parts. Is this continuous at x equals -1? 100% what has to go through your head is the three-part definition. You should be asking yourself, is there a point when x is -1? So the top piece says when x is equal to -1. So if I plug that in here, I would get 1/3. What's important is it exists. To make sure your graph's not jumping, you need to think about the limit as it approaches -1 from the left, and plug that into the right thing. You get 1/3. Think about the limit as it approaches -1 from the right. Make sure that you plug that into the correct part of the piecewise function. You get 3 to the -1, which is the same as 1/3. And since it's approaching the same number on the left and the right, we can say the limit as x approaches -1 does exist. That's the second part of the definition. And then the last part of the definition, the point, which is 1/3, has to be the same as the limit, which was also 1/3. So, is it continuous at x equals -1? Well, the short answer is yes, but your explanation or your justification has to be all of this stuff. You have to state that there's a point there, you have to state that the limit exists there, and third, you have to state that the limit equals the point. If your answer is yes, you have to state all three of these things. They're all required to prove continuity. Okay, but then if we try x equals 2, hopefully this one will be a little different for some variety here, but I would ask myself, is there a point at x equals 2? I look over here. The bottom one says when x equals 2, you plug it in here. So we would get 4 minus 1. So there is a point. I know that I got to think about the limits. So the limit from the left would be plugged into the top one. 3 squared. Got to compare it to the limit from the right, which would get plugged into the bottom one, which would be 4 minus 1 or 3. Okay, can you see how the graph's jumping now? At this one instant at x equals 2, it goes from approaching 9 from the left of it to approaching 3 to the right of it. So honestly, if this was my test question, I see what's wrong with it. I would say, I don't need any of this. I'm going to say no. And since the answer is no, you don't have to state all 3 things if the answer is no. Just state what's messed up. The limit as x approaches 2 from the left is not the same as the limit as x approaches 2 from the right. I'm not saying that you can't say that in words, but almost always students don't say it correctly in words. You want to practice it with the math notation. It's easier, it's more concise, and it's more reliable as far as getting points on the FAQs. So once again, don't try to think in your head. Don't try to think about what this graph looks like. Any of that's a waste of time. Make sure there's a point there. Make sure that the limit from the left is the same as the limit from the right. And make sure that the point equals the limit. If all those things are true, say yes and show those 3. If any of those things are wrong, say no, show which one's messed up. That's all. Try not to overthink it. Okay, so give me a few minutes here to get these homework assignments graded and in the grade book so I can pass those back to you. But our agenda shows the order that I'd like you to do these assignments. So continuity, which I just did a couple questions for you on, is what I'd like you to do first, please. So as soon as I get these in the grade book and passed back, I will offer to answer a few from that. That is one that I plan on taking up next class. Then finish today's handout, number 12, on types of discontinuities. And then if you have class time, go ahead and start on 13, but I will talk about that one more in detail in just a bit. So just start in that order, please.
Do you want me to circle this?
I do, yeah. Did you have a pass for being late? Huh?
No, but I will get it.
All right, feel free to work together and help each other until I start working on the board again.
Oh, so this question from
you maybe fill this out for me at some point. Just like drop it in the bin. Okay, awesome. Thank you.
I'll come by and see how much work you've done in a minute.
Alright. Should be interesting.
Let's aim for not interesting.
Alright, I'll do my best.
It's because they're not answers. Isn't it not that? Because that's what does it matter? Doesn't this matter if they're not equal? I just don't know what it works for. Okay.
Just a couple more minutes. Let me get these homeworks passed back so I don't forget. And then I help out some. Okay, I know, but they have you marked for this period. So I can't take that off, I just let you know. When you go to the office, let them know that you
You don't sound too good.
Yeah, I'm sick. Or I am suffering. And not inside.
It's fine. Okay, I know it's pretty quick here, but that should have been enough time for you to get a couple questions under your belt. So I assume most of you are still on the continuity worksheet. So is there any of them that you have tried, your answer didn't match up with what I have on the website, or you're stuck, or you don't know how to start it, or anything I can help with? What number? Number 5? Okay, so if I was working number 5, it says identify each type of discontinuities and where they are located. So the best thing that I could do is to just start off and assume that it is continuous, and I'm trying to prove that. So it might not be continuous at x equals -2, and it might not be continuous at x equals 4, because -2 is where it hands off from this to this to this, and x equals 4 is where it hands off from this to this. Individually, each of these three are continuous, but maybe not where they're handing off from one to the next. So at x equals -2, at least mentally, I'm going to start thinking about, is there a point there? Sure. When x equals -2, y equals 3. So the point exists, although I wouldn't normally write that down. If it's discontinuous there, maybe the limit doesn't exist. So I'm going to think about the limit from the left, which would be plugging in here. That would be -8 plus 6, which would be -2, versus the limit from the right, which would be plugged in here, which is negative square root of 6. Okay, and now you see how it's not continuous here because the limit doesn't exist. So I didn't really have to write this. What they want me to say is they want me to say, well, at -2 is discontinuous, and if it's going from a value of -2 to negative square root of 6, it is jumping. So that is a type of jump discontinuity. But there might be another one at x equals 4, so I have to check that as well. So I'm going to think about the point. When x equals 4, I would get negative square root of 6. That doesn't mess up continuity. Next, I would think about the limit. The limit from the left is negative. I'll write it out to make sure that you know what I'm talking about. The limit from the left of 4 would be negative square root of 16 plus 2, which would be square root of 18. The limit from the right of it would plug into this one, which would be natural log of 4. These two are definitely different, so the limit doesn't exist here either. So at x equals -2 and at x equals 4, both of those were jumps. Now, of course, just looking at that piecewise function, I had no idea that those were going to be jumps. You can't do that in your head. You need to force yourself to have a starting point. Force yourself to see the points exist. Force yourself to check that the limits from the left and the right are the same so that the limit exists. And if that's still true, make sure that the limit's equal to the point. If all of that's true, it's continuous there. If any of it's not true, it's not continuous there. And depending on why, or whether the point's not there, or if it's jumping or whatever, that's going to help you figure out what type of discontinuity. Okay, is anybody else going to ask about 5, have something more specific about it while it's still up? Yeah.
Are not removable at x equals
At x equals what?
negative 2?
-3?
Negative 2.
Oh, -2. Well, I don't have that work up here anymore, but here this would be -8 plus 6, which would be -2. So it looks like it's approaching -2 from the left. As x approaches -2 from the right, that was negative square root of 6, which is like, I don't know, negative square root of 4 would be -2, so negative square root of 6 is a little bit less than -2. Okay, and then at -2, it has a point of 3. Yeah, I'm going to stick with jump on this one, because except for this one instant at x equals -2, it was up here, and then at an instant, the rest of the function jumps down there. So I'm still going to go with jump. Now, if these were the same, and this had a point up there, and it had a hole here, then I would agree it would be removable. But I think those are both jump. Okay, let's do a couple more if you have them ready. So just focus on continuity worksheet. Anything else you found on that yet? Okay, let me give you a couple more minutes there then. Oh, Christopher. Okay. There's also a couple on here you forgot. You need to do those two.
So for number 6, if like
Yeah.
if the both of the limits are the same, how do you find if it has a hole or not?
Well, so it's approaching -1 from the left. It's approaching -1 from the right. But what's the point? What's the y value when x equals -1?
It would be this, which would be the same.
No, right here.
Oh,
This is the,
I see,
so
yeah.
it's y is 3 when x is negative 1.
Okay, yeah. That's
So
okay.
yeah, that point's up,
You
not
just
where
have
it
to
needs
look
to
at
be, so it's removable. Well, I wanna see how much work you got done. That was free.
Slower today.
I know that.
Always slow.
I've done it freshman softball, and I already think I have 4 hours just
Are you doing okay?
I'm doing fine. Thank you so much.
And do actual volunteer.
Yeah, so it's approaching 0 from the left, 0 from the right, but then at that instant it's down here at -2. So if it's just that one time, that's the whole lot. It'll be-
$20.
It was fun.
I don't remember the first one. Are we in the same class?
That's it. It was so sweet. I cannot.
Okay, well, if you approach
And then I
one,
got another job.
one from the left, that would be here.
It's actually
-1
funny.
-6 would be, and one from the right would be here.
Yeah.
That's 3 no matter what x is. So it's jumping, so from this to this in an instant, the whole graph.
Algebra.
You want one
can't afford it.
I wish like it was just free. Like, how did they do that?
You should just read.
I think they get more business.
Learn to make one is
Wait, I should.
confusing. It's gotta be difficult.
Oh yeah, that's a good one.
These can be bad.
So you notice that those two equal to each other.
The more Puritan this is, it's from
Okay,
someone.
you have an equation here, but you don't have an equation here, so what happens?
Oh, yeah, so like.
Oh, okay, here's your equation.
That's crazy.
Very good. You do want to set it equal to 0.
So essentially the world is just melting.
Right.
Maybe I'm just working.
Yeah, it's doing the rest of it.
Okay, now, do you really, you want these to be continuous, right? But for them to be continuous, the part you need to understand is, let's say, I don't know. Let's say one of them is something like this, and one of them is something like, I don't know, that. For these to be one big continuous thing, what has to happen?
They have to equal at x equals 2.
Okay, perfect, you said that perfect. So, we want these to be in the same place, right? So they gotta like connect somehow, right? But notice, I could care less if there's the same value, except at that one time. So if you plug that x value in, then the only thing you have to solve for is k's. Okay, you doing okay? You guys got anything I can look at here to help? Everyone okay?
Quick question.
Yep.
So on the solutions, they put it the equals -1. You put like it's gonna be instead.
Yeah, that's what it should be. Those are not my answer keys, but based on the directions, we want to know the type of discontinuity, so yeah, they shouldn't have said vertical, they should have said infinite.
Okay.
Vertical is what I would describe, vertical asymptote is how I would describe the graph, but it's asked about continuity, so infinite is what you should
Okay,
have.
thank you.
You doing okay? Calculator active. It means you're welcome to use one. On the AP exam, when they let you calculator actually helps with what can happen. Oh, so you can try it without one, but there's a good chance you'll need it. Okay, any math stuff I can help with right now? You doing okay?
Here, that's my headphones.
That's heavy duty. Like,
So
like drop proofs, you know. Are they, they're pods or?
They're like, there's so many by
Yes. And then by the type of discomfort.
Yeah, I got
You can
one
also,
for,
I don't know.
in -2.
I want you to have to go back. So basically, it's vertical, it's making it, hold.
So.
You're describing what's happening on the graph, but you're not referring to the type of graph. It's amazing that that's almost not enough space for one question. Okay, can I help over here?
It takes so much writing to
Yeah.
do one.
Yeah, the problem is they take several before it really sinks in what you should be doing. If I only gave you 2 or 3, I wouldn't remember it at all, so. Now you're getting sick.
Everyone in Canada like videograph COVID. I know, yeah.
Everyone's-
I love you, love you. Sorry. I have been on stage for years. Like locked in your
All right, you guys still have about 30 minutes, so should get significantly more work done before it's over with.
I just like my exchange, like I'm just like
Get out of bed one day, like, oh my gosh.
Because I learned how to do it. Yeah, we did this one time.
I don't know. If we plug in -7 for K.
I don't know, something like that. I don't think so. It's like, it's just sick.
Let me glance at my work real fast. Is that what the plan is to be doing?
We can't reduce, like, we just do those for you.
E is just, it's not the same, but it works the same as pi. It's not the same number as pi.
Oh, okay.
Just like you couldn't reduce 4 pi, you can't reduce 4e.
Or wait, no, it's jump.
Oh, sorry, I hadn't marked that one yet. Okay, I had a question for number 11, so if it will help you to watch me go over 11, then you might want to jump to that. And if not, that's okay too. You can always watch it later, I guess. Okay, so to make sure that this is continuous, I got to figure out what value of k. So k is just some generic number, but some value of k that makes this continuous. So I've got this, which I'll go ahead and FOIL. And I've got this that I can't do much with. But I think once you guys get to this point, you realize that these two things need to be equal. But the truth is, I don't really care about this guy's y values, nor do I care about this guy's y values, except at this time. At this time, I need to make sure that whatever this guy's y value is, this guy's y value is the same thing. That makes sure that they're connected and going to be continuous. So I only really care that these two things are equal when x equals 2. So if I plug in a 2 into this, a 2 in for x, it's going to look like that. And now the hard part should be over. I know it looks kind of messy, but this is a quadratic. Anytime you solve a quadratic, you want to get everything on one side set equal to 0. 7, 8k, add 1 plus 7. Is that looking okay? So, okay. I'm just going quickly, so I was afraid I might have had a mistake. So then you've got a quadratic, which we're going to hope solves with factoring. And it looks like -1 and -7. Those two values of k should make that work. Yeah, that's what I got. Okay, so did that help, or did you find your mistake in there? Oh yeah, yeah. When you solve this, there could be two different answers. Okay, anybody want to ask anything specific about 11 while it's still up there?
You go to 14.
I will. Just make sure that you guys understand with these questions, there's really two big hurdles you need to be aware of. There's the first hurdle of knowing how to approach the question. That should get easier as you practice more. And then there's the second hurdle of actually being able to do the question. Being able to solve this, solve the quadratic, factor it correctly. So the actual work should take you longer, but the first part is also very important. What'd you say, 14? Okay, so let me do this one more from this assignment, and then I know some of you have moved on to the handout y'all picked up today, so I will take some questions from it next. Okay, 14. Let f be the function x over natural log of x squared. Which of the following conditions explain why f is not continuous at x equals 1? Okay, so in my mind, I know the three-part definition to be continuous, so part of that needs to be messed up. So in my head, I'm just going through those one at a time. I know there's supposed to be a point there, so I want to see if that's what's wrong. If I plug in 1 for x, I get this. 1 squared is 1, and what is the natural log of 1?
0.
Okay, and what does a number other than 0 divided by 0 give us? Right, you can't divide by 0. So f of 1 does not exist. So that can't be a, because a says it does exist. It can't be c, because it says there's a point there as well. But it could be b or d, just thinking about the point. Okay, so the next thing I guess we would need to do is we could think about try to think about the limit. Although this one might be tough to do with how much we currently know. Oh, well, wait a second. This is calculator active. So that's how you're supposed to know how to do this one. If this is calculator active, you should be using your calculator if it at all helps. You could graph this. X over natural log of x squared. I care about at x equals 1. Okay, so sure enough, at x equals 1, I could have started here to see that it was not continuous at x equals 1, but now I can also see why. It approaches negative infinity on the left, positive infinity on the right. Therefore, it's approaching two different things, so the limit doesn't exist either. So that's why they should have picked D for that. The point doesn't exist, and the limit doesn't exist. Plugging in that x value does not return a y value, and this approaches one thing on the left and something different on the right, which means its limit does not exist. Okay, so I know some of you have started moving on to assignment 12, so for those of you that have, on our types of discontinuity that we took notes on this morning, is there any of these you would like a reminder or two on? We still got about 20 minutes of class, so I'm gonna give you about 10 more minutes. I'll give you one more chance to take questions on the board. Then I'll make sure you know exactly what your homework is, how much of this stuff you need to have done by Thursday. I will remind you that our first quiz is coming up, so it's not next class, but the class after. So something to keep in mind.
You feel this out?
Sure. Wait just a second. We'll do it right now. I didn't know you came from Hossall.
Yeah.
Do you miss it?
Not really. Just some of the people.
Go. I got about 9 minutes left, so for me to answer a couple more questions, I need to start taking those. Okay, so it can be from the continuity worksheet, or it could be from the types of discontinuity worksheet, either one. Anything I can help with.
Can you do number 6 on 12?
Number 6 on 12. This one? Okay, well first let's write it as a fraction. So we're going to have to use one of our trig identities to do that. The good news is it takes almost no amount of time to figure out nothing makes the numerator 0. But there are some things that make the denominator 0. So like the one we had to do on the front page, if you're trying to figure out where the denominator equals 0, if it's a multi or half angle like this, this is considered a double angle. Temporarily pretend like it's just a regular x. Go around the unit circle and think about everywhere where that happens. Cosine is 0 at pi over 2 for the first time. And then all the coterminal answers are integer multiples of pi away. But I didn't solve for for x, I solved for 2x. So divide this by 2, divide this by 2, and divide this by 2. And now I have what is a formula that will tell me everything that makes the cosine of 2x equal to 0, which is also the denominator here. So one answer is pi over 4. The next answer comes from adding pi over 2 to that. So that would be here at 3 pi over 4. Add pi over 2 again. 5 pi over 4, add pi over 2 again, 7 pi over 4. So it looks like there is 4 numbers that make just the denominator 0. So all of those are going to be discontinuous for those x values. And since they're making the denominator equal to 0 and not the numerator, those are going to show up as vertical asymptotes, which we in calculus call an infinite discontinuity. Is that enough? Okay. It's just that you got to dig pretty deep. The good news is this doesn't come up on the AP exam too much, where you have to solve things like cosine 2x or sine 2x. I don't think they ask those type of questions anymore, but still good practice. Okay, so first off, let me make sure that you know what your homework is, and I haven't said all of it. So number 10 should have been finished. I'll let you ask questions for that, so I will have you turn that one in next time. But again, it should have already been finished. I also plan on taking up 11 and 12. So it sounds like a lot of you, or most of you at least, were finishing up assignment 11. So that's great. That means no homework from that. But I don't think many of you finished up number 12. So I need you to finish that up, please. Okay, I did not mention 13 yet, so let me speak on that. You should do some of 13, but you do not have to come to class with that one finished. This is a rather long, it's just a review, so it's just trying to remind you of some of the stuff we've done these first 2 weeks. How much of assignment 13 you should do before Thursday should be proportional to how prepared you feel like you are for this upcoming quiz. If you feel like you could take the quiz right now and probably make an A or a B, just do a little bit of the review. If you feel like if you took the quiz right now, you know you would flunk it, you should probably do more on the review to make sure that you're pushing yourself in the right direction more. On Thursday, I will give you class time to work on the review, but what you need to understand is Thursday you need to finish the review in class in time to find your questions you need help with, in time for me to actually help you with those. If you don't do any of assignment 13 between now and Thursday, that's not going to happen. You're going to get some of it done in class, you're going to get some of your questions answered, but then you're going to have to finish it up for homework and you're going to find other questions that you have. And at that point, you've already seen me the last time before our quiz, because our quiz is not next class but the class after. So make sure that you do some of it, and it's even fine if you just do some of the easiest stuff, so that's achievable on Thursday. Okay, is there any questions about the homework part? that's all I've got for you guys. I don't have a puzzle for you today, but I do have something different if we have 2 volunteers. And if not, that's okay also. But is there 2 people in here that feel like they can solve Rubik's Cubes pretty quickly that would be willing to race? Well, she took it down when I said race, so. Anybody want to race? Will? Chris? Okay, you 2 come up to the front of the room. Okay, go in the front there, stand back to back so you can't see each other. I gotta shuffle these up from my last period. Alright, Chris is on y'all's left. Raise your hand if you think Chris is gonna be the winner. Oh wow. Okay. And then on your right is Will, is that correct? Okay, raise your hand if you think Will's gonna be the winner. Alright, so most people think Chris is gonna win. Okay. You ready? Set. Start.
Whoa, that's fun.
Come on, Chris, you gotta speed up. Is done. Now help him with Yeah, it was not a fair fight. Good sport. Yeah, that was great. Take one first. Yeah. I did not. I don't think so.